In this deck, we're going to look at how Claude Code orchestrates multiple agents, how it spawns workers, coordinates them, forks context, lets agents talk to each other, and even controls remote machines. This is the full multi-agent architecture from the source code, explained from the ground up. Let's get into it. There are three distinct layers to understand. First, the agent type taxonomy. There are 5 kinds of child agent, each with different isolation and capabilities. Second, coordinator mode and fork subagents, how the main session orchestrates workers in parallel, synthesizes results, and redispatches. And third, peer-to-peer communication and the bridge layer, how agents talk to each other, even across machines. Each layer builds on the previous one. Every child agent spawned by Claude Code becomes a task state entry in app state. The most common type is local agent, an in-process background subagent that runs async and notifies you with the task notification XML block when it's done. Remote agent runs in Anthropic's cloud, useful for long-running or isolated work. Teammates are peer agents in a swarm, and forks are a special experimental type that inherit the parent's full conversation context. There are also simpler types for shell commands and workflows. There are 8 built-in agent types. General purpose is the catch-all. Explore is read-only. It can glob, grep, and read, but never edit. Plan is for architecture work without touching files. Verification gives an independent code review. Claude-Code-Guide answers questions about Claude Code itself. Status line setup handles a narrow configuration task. Worker is only available in coordinator mode, and fork, which is experimental, inherits the parent's full context. You can also load custom agents from .claude/agents markdown files. The fork subagent is worth understanding in detail. When you call agent without a subagent type and the fork gate is on, the child gets the parent's full conversation, system prompt, all message history, and the current assistant turn, with only one thing different: a unique directive appended at the end. The key design insight is prompt cache sharing. Because all fork siblings get byte-identical prefixes, they all hit the same Anthropic API cache bucket. Only the final directive bytes differ, so the cache hit rate stays high even with many parallel forks. Here's the fork pattern in practice. You call agent 3 times in a single turn, fix the bug, write tests, update the changelog. Each child gets the exact same conversation prefix, then its own directive. They all run in parallel. There are strict rules injected into each fork child. Don't spawn subagents. Use tools silently, commit before reporting, and start your response with scope : This keeps fork output structured and concise. Forks can't fork again. There's a guard that detects the fork boilerplate tag in conversation history. Coordinator mode is activated by setting Claude-Code coordinator mode = 1. The main session becomes an orchestrator. It plans, delegates, synthesis, and reports to the user, but never does implementation work directly. The coordinator has 3 tools: agent to spawn a new worker, send message to continue an existing worker, and task stop to abort one mid-flight. Work follows 4 phases: research in parallel, synthesis by the coordinator, implementation by workers, and verification by a fresh independent worker. Let's trace the coordinator loop. The user asks to fix a bug. The coordinator spawns 2 research workers in parallel, one investigating the bug location, one looking at test coverage. While they run, the coordinator waits. When a worker finishes, it sends a task notification as a user role message. The coordinator reads the findings, synthesizes them into a specific implementation spec with file paths and line numbers, and then continues that worker with send message. The worker edits files, runs tests, commits, and reports done. Parallelism is the coordinator's superpower. Read-only research tasks can run in as many parallel workers as you want. There are no write conflicts. Implementation workers should be serialized per file set to avoid merge conflicts. But different file areas can run in parallel. Verification can often run alongside implementation if they're in different parts of the codebase. When a worker fails, don't spawn fresh immediately. Continue the same worker with send message because it already has the error context and knows what it tried. Synthesis is the coordinator's most important job and the hardest to get right. When workers return research findings, the coordinator must read those findings and write a prompt that proves it understood them. The spec should include specific file paths, line numbers, the root cause, the exact fix, and what done looks like. Never write phrases like, based on your findings, or the worker found an issue. Those delegate understanding back to the worker. Workers can't see your conversation. Every prompt must be completely self-contained. After synthesis, decide whether to continue an existing worker with send message or spawn a fresh one with agent. The deciding factor is context overlap. If the research worker explored exactly the files that need editing, continue it. It already has those files in context. If the research was broad but implementation is narrow, spawn fresh to avoid dragging noise. For corrections, always continue. The worker has the error context. For verification, always spawn fresh. You want an independent perspective that isn't anchored to the implementation worker's assumptions. Agent swarms are a different coordination model from coordinator worker. Instead of a hierarchy, teammates are peers. Each runs as a full Claude Code process or runs in process with async local storage for context isolation. There are 3 execution backends. In process is fastest and shares the API client. TMUX panes give you visible split terminals, and iTerm2 panes use native split views. The team roster is flat. Teammates can't spawn other teammates. Communication goes through a shared file-based mailbox system. The send message tool routes differently depending on the to-field prefix. No prefix means intra-team mailbox, writes to a JSON file in .claude/teams/team-name/inboxes. An asterisk broadcasts to all team members. The UDS: prefix routes to a Unix domain socket on the same machine, useful for tool integrations and MCP bridges. And bridge: routes cross-machine via Anthropic servers, arriving as a user prompt on the peer Claude. Each channel has different constraints on structured versus plain text messages. The intra-team mailbox is a JSON file with file locking. Each write retries up to 10 times with exponential backoff between 5 and 100 milliseconds. This handles concurrent writes from multiple Claude processes without data loss. Beyond plain text, 3 structured message types travel through the mailbox. Shutdown request lets the team lead ask a teammate to stop gracefully. The teammate responds with shutdown response, either approving, which triggers an abort controller, or rejecting with a reason. Plan approval response is for teammates that require plan mode approval before implementing. The bridge layer is what powers remote control, the ability to use Claude.ai or your phone to drive a Claude Code session running on your laptop or server. Run Claude Remote Control to start a bridge. It registers a persistent environment with Anthropic's Environments API, then polls for work items. When a work item arrives, meaning someone started a session from Claude.ai, the bridge decodes a signed JWT called a work secret, forks a child Claude process, and connects it to the session ingress. Let's step through the bridge main loop. First, register bridge environment to get an environment ID and secret. Then enter a continuous poll loop calling poll for work. When a work response arrives, decode the work secret JWT, which contains API base URLs, access tokens, Git source info, and MCP config. Acknowledge the work, Then call session spawner.spawn to fork the child process. Meanwhile, heartbeat work on an interval to extend the server-side lease and prevent timeout. The transport is either a WebSocket for CCR version 1 or SSE for version 2. The bridge supports 3 spawn modes. Single session is the simplest. 1 session at a time in the current directory. Bridge tears down when it ends. Worktree mode is the safest for multiple concurrent users. Each session gets an isolated Git worktree so they can't stomp each other's changes. Same dir mode lets all sessions share the current directory, which is faster, but means concurrent sessions can conflict. Each running session is represented by a session handle with a done promise, kill and force kill methods, and a ring buffer of the last 10 activities for the status display. Bridge messaging lets one Claude talk to a Claude running on a completely different machine. Use send message with bridge : followed by the session ID. The message routes via Anthropic servers to the peer session's ingress, where it arrives as a user prompt on the receiving Claude. This is strictly plain text. Structured messages can't travel cross-machine. Critically, every bridge message requires explicit user permission. It's a safety check, not a permission mode check, meaning it can never be auto-approved even in bypass mode. This prevents cross-machine prompt injection. Here's how it all fits together. The user talks to the main session. In coordinator mode, that session spawns async workers, receives task notifications, synthesizes findings, and redispatches. Workers communicate back via task notifications. In swarm mode, teammates talk through 4 channels: mailbox for most messages, broadcast for team-wide alerts, UDS for same machine tool integrations, and bridge for cross-machine. The bridge layer lets remote web or mobile clients drive a local Claude process with full tool access. 3 key takeaways. The coordinator synthesizes, parallelism is the superpower, and communication is layered. If you want to dig into the source code, here's the map. Agent types live in src/tools/agent tool. The main tool, fork logic, and built-in agent registry. Task lifecycle is in src/tasks. Coordinator mode is in src/coordinator. Send message routing is in src/tools/send message tool. Swarm backends are in src/utils/swarm/backends. The mailbox protocol is in src/utils/teammate mailbox. And the entire bridge layer is in src/bridge. Bridge main, bridge AP, session runner, transport, and peer sessions. Thanks for watching.